Greetings, fellow Flutter Shinobi, and welcome back to the Society of Flutter Shinobi. I'm your host, Kun, and today we have another special episode, Design Patterns. So, what is a design pattern? For some of you that don't know, a design pattern is a reusable and general solution to a recurring problem in software design. It's essentially a blueprint or a template for solving common issues that developers encounter while designing and structuring their software systems. Design patterns provide a structured approach to solving problems, improving code readability, and promoting software maintainability. Design patterns are not tied to any specific programming language or technology. Instead, they are a high-level concept and guidelines that can be applied to various software development scenarios. The concept of design patterns gained widespread recognition and codification through the book Design Patterns, Elements of Reusable Object-Oriented Software, published in 1994. The authors of this influential book are often referred to as the Gang of Four, or GOF, and they include Eric Gamma, Richard Helm, Ralph Johnson, and John Vlasides. Their work was based on years of experience and research in software development, and it has since become a foundational reference for software engineers and designers worldwide. In the world of Flutter development, just like the life of a ninja, there are moments when you need to adapt to different solutions. That's where our secret weapon, the strategy pattern, comes into play. So imagine a ninja skilled in various weapons, choosing the right one for each battle. Similarly, the strategy pattern allows us to select different strategies based on the situation. Let's dive into the code and see how we can implement and switch strategies using the strategy pattern. Here we have our Flutter application. We'll create different strategies for attacking, defending, and retreating, just like our ninja adapting to different situations. At the beginning of the code, an abstract class or interface called battle strategy is defined. This is like a blueprint for different battle strategies. It has one method called execute, which represents what happens when a specific strategy is executed. Below the interface, there are three classes: Ninja Attack Strategy, Ninja Defend Strategy, and Ninja Retreat Strategy. Each of these classes implements the battle strategy interface by providing its own implementation of the execute method. These classes represent different strategies a ninja can use in battle, such as attacking, defending, or retreating. The main function is the entry point of the program. Inside the main function, a ninja object of the ninja class is created. This ninja will be able to switch between different strategies. The ninja class has a private member called strategy, which is a type of battle strategy. This member holds the currently selected strategy. It has three methods: set strategy, attack, defend, and retreat. Set strategy allows you to change the current strategy of the ninja. Attack, defend, and retreat all call the execute method on the current strategy. So, depending on the current strategy, one of these methods will print the corresponding message to the console. Now, just like our ninja adapting to different foes, we can easily switch between strategies in our own code. Let's run this code and see what each says in the console. The Ninja object is configured to use different strategies by calling the setStrategy method on it. First, it sets the strategy to Ninja attack strategy, and then calls Ninja attack, which executes the attack strategy and prints Ninja strikes with precision and speed to the console. Similarly, it sets and uses the defend and retreat strategies. So, besides this, let's get a little deeper into why using this design pattern is good for developers. Number 1, flexibility. It allows you to define a family of algorithms, encapsulate each one, and make them interchangeable. This means you can easily switch between different strategies at runtime without altering the context that uses them. Next, maintainability. By encapsulating algorithms in separate classes, you promote a clean and modular code structure. Changes or additions to strategies won't affect the rest of the code, making maintenance easier. Reusability. Strategies are encapsulated in their own classes, making straightforward to use them in different parts of your application or even in entirely different projects. Testability. Since each strategy is isolated, it's easier to write unit tests for individual strategies, ensuring they work correctly in isolation. Complex decision making. It's beneficial when you have a complex decision-making process that can be broken down into multiple strategies. For example, in games, you might have different AI strategies for enemy behavior. Dynamic behavior. When you need to change an object's behavior dynamically at runtime, the strategy pattern shines. It's especially useful when you have a range of possible behaviors and want to select one based on changing conditions. And lastly, reducing conditional statements. Each helps in avoiding a cascade of conditional statements, if, else, or switch case, by encapsulating each behavior in its own class. This makes your code more maintainable and less error-prone. So, the strategy pattern can be used in various scenarios across software development, where you need to manage different algorithms, behaviors, or strategies. Here are some common areas when this pattern is beneficial. Sorting algorithms. You can implement sorting algorithms such as the bubble sort, quick sort, merge sort, using the strategy pattern. This allows you to switch between sorting strategies without changing the sorting code. File compression. Different compression algorithms such as zip, gzip, and LZ77 can be encapsulated as strategies, making it easier to switch between compression methods. Payment processing. In an e-commerce application, you can use the strategy pattern to handle various payment methods, such as with a credit card, PayPal, Apple Pay, and so on, as separate strategies. Authentication. Implementing different authentication methods such as your username and password, OAuth, JWT, using the strategy pattern to support various login options. Database access. Depending on the database type, such as if it's a MySQL, a PostgreSQL, MongoDB, you can easily use a strategy pattern to manage database connections and queries. AI in game development. Strategies can be used to define various behaviors for game characters or AI agents. For example, you might have different strategies for enemy movements or decision making. Caching. Implement different caching strategies such as in-memory cache, distributed cache to improve system performance and scalability. UI design. Customize the user interface behavior based on different user preferences or device types using the strategy pattern. Network communication. Switch between different communication protocols such as HTTP, WebSocket, MQTT when building networked applications. Logging and error handling. Customize logging and error handling strategies such as writing to logs or to a file, sending alerts, or displaying them in the console. Business rules. Manage complex business rules and decision-making processes by encapsulating them as strategies, allowing for easy modifications and testing. And there you have it, fellow Flutter Shinobi. The strategy pattern allows us to change our application's behavior dynamically, just like a ninja adapting to new strategies. Remember, the path to mastery, whether it's in coding or the way of the ninja, is about adaptability and continuous learning. That's all for today's special episode on strategy pattern. So if you found this episode enlightening, don't forget to like, subscribe, and hit that notification bell to join and stay updated on our journey through the realms of growing Flutter Shinobi community. Until then, keep coding, keep practicing, and remember, the path to mastery is a path of the ninja.